Hi guys, let's see the object which is present on the screen. Almost all you know these all. So this is a microscope, first one, which you used to see very small objects which we cannot see with our open eyes or naked eyes. So those objects which we can see with this instrument known as microscope. And next to that it's a telescope. So this is the opposite function of the microscope. So telescope we used to use to see far away objects, just like celestial objects known as planets, stars, to see them very clearly. And next to that it's a camera, a lens camera. And next to that a lady is inserting a contact lens, and below that projector, a projector, and human eye. And the last one, a simple microscope or a small lens which we can see the letters in bigger in size. So the common things in these are is nothing but lenses. So these all instruments contains commonly. So that is known as lenses. So let's look about lens. So if you define lens as, a lens is a piece of transparent material with two refracting surfaces such that at least one is curved and refractive index of its material is different from that of the surroundings. So it's a very big definition, don't worry about that. First you can just know what a lens means or what it contains. Usually lens contains what? It's a piece of transparent material. I hope you know what is the meaning of transparent. And it contains two refracting surfaces. Refracting. We know the phenomena of refracting. So when light travels one medium to another medium, it will bend towards to the normal. So that phenomena we know as refraction. And each material having refractive index. So this refraction takes place between two things. These lenses are two types. So many types are there, different types, but we will exclusively talk about these two types. One is known as a double convex lens, another one is a double concave lens. So this lens we known as a double convex lens. So this is a convex surface which highlighting it here. So this lens is known as double convex lens, and this surface we known as double concave lens. So these are the two lenses we will talk first. Other than these two categories, plano convex lens, plano concave lens, convex concave lens, depends upon the combination. So first we will learn about these two lenses. So let us learn how to make a lens. To make a lens, what we need? To make a lens, we need to take two spherical balls, or I can write that as a known as a two glass balls, because glass is a transparent glass balls. Suppose if this is a glass ball having a radius of r1. Suppose if I make this as a copy and if I can keep this like that. Now if I take 1 and if I make an intersection like this, so we can see that if you see that these are the two different spheres. So this is having a radius r1 and it is also having the radius r. But if we can keep that lenses together and if we can cut this intersection part, which is I am going to highlight. So if we can cut this intersection part only, so we get a double convex lens, the intersection part of these two. So this we known as a simply a convex lens. It's having two curvatures. Suppose if I call this as a sphere's first sphere having center of curvature C1, and this is the another sphere, second sphere having center of curvature C2. And if you can see, if this is a sphere and this is one of the radius of curvature. So if you can see another, so C2 is the center of curvature of the another sphere and this portion is the another radius of curvature. So if I can take the intersection part of that two, if I can take the intersection part of that two, so it may comes like that. So if we can take this middle portion, so the mid portion of that two spherical surfaces, we call it as convex lens. So this convex lens is having two curvatures. So since it's transparent, so they both will be reflect the light. Now coming to the concave, so we'll take the same. First let me take a sphere. So we need to take a spherical surface of ball. So this is a circle. If you can take this as one more circle and to make a concave lens, so this time we need to keep certain distance. And if we can take the mid portion to make a concave lens, if you can take the mid portion between them, so this is the mid portion between the concave between the two spherical surfaces, and this portion will be acts as our concave lens. Now to this concave lens also we are having two curvatures. So this is the curvature for the sphere 1, which is having center of curvature C1. Another sphere if you can take, so this is the another sphere 2, which is having center of curvature C2. And the mid portion, so the mid portion of these two will be act as our, so this lens we call as concave lens. So this is how to make a convex lens and how to make a concave lens. So convex lens and concave lens. Now here you can see, so this is the convex lens and it is having two curvatures. Now how light refracts? So when light strikes on one surface, so this is the incident light, so that is striking on the curvature in one surface, what happens? According to phenomena of refraction, the light bend towards to the normal when it is traveling from rarer to denser medium. So lens is a glass material which is having another refractive index value than the surroundings, so it will bend towards to the normal. So here the red line, if you can see, so that is bending towards to the normal, and when it is coming out from the glass to air outside, it is bending away from the normal. So that's why this phenomena we known as refraction, bending of light. Suppose if we take so many light rays, so these all are the light rays. So these light rays all are striking on the lens, and after refraction, so they will be concentrating at a point. So this point we known as focal point or focus. So that's for the convex lens. Suppose if you can see an experimental, so this is the convex lens and the concave lens together. So when light is strikes on convex lens and concave lens, so on the top if you can see, so this left side, so these are the parallel rays, the laser, the pink laser which is striking on this convex lens. Now here you can see, after refraction, the rays are the traveling inside the lens, and after they are focusing at a particular point. So that point we can call as focal point. So this lens we also known as converging lens. Why? Because light rays are the coming all the way like that, then they are passing through the lens, then after they are converging. Converging means they are the concentrating at a point. So this is known as converging. So convex lens is known as converging lens. Similar to concave lens, another lens is known as concave lens. So concave lens, you see, is exactly opposite to the convex lens. From the left side, light rays are the striking on the lens. After refraction, light is traveling inside the lens and it is diverging, means the refracted rays are the going separately. So they are not all coming together, they are going away from each other. So that's why this concave lens we call as diverging lens. So convex lens is also known as converging lens and concave lens is also known as diverging lens. So these two lenses together we known as spherical lenses because they are having the curvature. So because of the curvature, we call them as spherical lenses. So these two parts will be tells about how the light ray will be refracts after passing through the lenses. So one for the convex lens and one for the concave lens. So convex lens is known as converging lens and concave lens which is known as diverging lens. Now let us learn certain terminology, so which we already dealt in the previous class. So just recall what we learned. So to make any lens, so what shall I need? I need first a spherical surface. So to this spherical surface, it's having a radius of curvature. Suppose this is as the center and this is having radius of curvature, and similar to this one is also having radius of curvature. Okay, so how we made a lens? So we took the intersection part of that too. So the intersection part of between these two. So this became our lens. So we can strictly call that as convex lens. The intersection part. Okay. Now, if I draw an imaginary line which is passing these two center of curvatures. Now, this imaginary line we call as principal axis. Principal axis. The principal axis should pass us to the C1 center of curvature and it passes to the C2 center of curvature, and the midpoint of the lens. The midpoint of the lens we call as optical center. So this term we known as optical center. Okay. Now this lens having two curvatures. So one is, so this is the ones, and another is opposite to that, this is the one. Okay. So with the help of these two are the different curvatures, and since it is having two curvatures, so it should have two focuses. So any side we can keep the object, so it can form the image other side. Now in that case we will be strictly use Cartesian sign convention. According to that sign convention we will keep object always on the left side. So if you can keep object on this side through this lens, so the light rays will be focused at here. Now this we can call as the focus. Okay. Now if you can draw same for the another lens, if you can take for a concave lens. Suppose if it is concave lens, so this lens is made up of two curvatures. So this is the one sphere and this is another sphere. For a moment. So if you draw an imaginary line, so which is passing through that. So this point, if you can take, this is the first sphere having center of curvature C1. This is the another sphere, second sphere having center of curvature C2. And the mid portion is known as, so this mid portion of the lens is known as optical center. And rest of the definitions as usual. The aperture. The aperture we can define as the maximum height of the lens. So this we define as aperture. The height of the lens we define as aperture. Similarly, it is also having two focuses. We can call as this side focus, we can call as focus F1, and this side we call as focus F2. Now let's learn about certain rules, image formation rules by the lenses. Now we learned similar question in the mirrors. So the same rules here we will be see one more time. Now this left side portion, this left side tells about the convex lens and the right side tells about the concave lens. We can see the rules parallelly. The first rule same to the both, that is, so if a light ray which is passing through the optical center, so in this first diagram if you can see both left and right, a light ray which is passing through the optical center. So optical center I defined as the mid portion of the lens is known as optical center. So a light ray which is passing through the optical center, so it do not deviate. So there is no refraction in this first case. So the light ray is straight away going from one side to the another side if it is passing through the optical center. So the light ray do not refract if it is passing through the optical center. So that is the first rule. And second rule, a light ray which is parallel to principal axis, after refraction it passes through the other side of lens. So in this case if you can see, so this is the light ray which is parallel to the principal axis. So a light ray which is parallel to the principal axis. So this is the light ray which is parallel to principal axis. After refraction, so the other side light ray if you can see, so this is the refracted light ray. So this is a passing through the focus F2 on other side. As per I said, the lens having the two focuses because these two surfaces are made up of two different spherical surfaces. They are having two different curvatures. Obviously, they should have two focuses. Now you can see the third rule. The third rule, a light ray which is passing through the focus. Now in this case, a light ray which is passing through the focus. Now a light ray which is passing through the focus, and after refraction it is parallel to the principal axis. So this rule is opposite to the earlier ones. A light ray which is passing through the focus after refraction goes parallel to the principal axis. So these three very simple rules for the convex lens. See once again, for the convex lens, a light ray which is passing through the optical center. A light ray which is passing through the optical center, so it do not deviate. So that is the first one. The second one, a light ray which is parallel to the principal axis. After refraction, it should passes through the focus. Third one, a light ray which is passing through the focus. After refraction, it is parallel to the principal axis. So these three simple rules we will be follow, and we will use these rules to draw ray diagrams for the convex lens. So see my right side on the screen. So these are the rules for the ray diagrams for concave lens. So the first rule in both the cases is same. So that is, if a light ray passing through the optical center of a concave lens, it do not deviate. So if I draw a light ray which is passing through the optical center, so these light rays do not deviate. There is no refraction in that case. Now you can see the second case. Now a light ray which is parallel to the principal axis. So this is a light ray which is parallel to the principal axis. So after refraction, so the light ray is refracting. So this is the refracting light ray. Now, if you draw the refracted light ray, so the refracted light ray R appears to come from a focus. So the ray of light appears to diverge. So this is the refracted light ray which already diverged. It is going away. So but this diverged light ray is appears to come from the focus. It appears to come from the focus. Appears means it appears, but it is not real. It just appears to come from the focus. And one more rule for the concave lenses: a ray of light directed towards the focus. Now if you can see, a ray is directed towards the focus. So but the light is not going to the focus because the lens will be refract the light ray. So the refracted ray, so this is the refracted light ray. The refracted ray is parallel to principal axis. Now this rule we can say that a ray of light directed towards the focus, after refraction it goes parallel to the principal axis. So these are the similar rules what we learn in the mirrors, and the same rules we can use for the lenses in the different manner. That's it. So see once more again these rules for the concave lenses. For the concave lenses, first rule: a ray which is passing through optical center. Optical center means the mid portion, the midpoint of the lens. A ray which is passing through optical center, so it do not deviate. That's the first rule for the concave lenses. Since concave lens is a diverging lens, all the diverging rays appears to come from the focus. So in the second rule, if you can see, so this ray is a diverged ray. Now this diverged ray appears to come from the focus. It appears to come from the focus, but it is not coming up straight like that. But this ray is refracting at here. So a ray of light appears to diverge from the focus on the same side of the lens. And the final rule: a ray of light directed towards the focus, after refraction it goes parallel to the principal axis. So these are the simple rules we will be following carefully to draw the corresponding ray diagrams for the coming concepts.